All right, so this is getting to know model-driven management with the Yang catalog, and I thank you very much for having invited me. So before we get started, how many people remember SNMP? A lot of people raised their hands because we don't just remember it, we live it. Color-wise, that got really weird, but anyway, SNMP, as you may remember, or as you know and kind of love, provides you data from the device, operational data, some configuration data from your network elements, and it provides it in this nice ASN.1 syntax where you have these dotted decimal OIDs. And you look at that and you stare at that and you're thinking, well, that's great. I see some numbers on the left of an equal sign. I see a number on the right. What is that telling me? Fortunately, SNMP provided this management information base, or MIB module, that would give us that translation, that capability. So we would have to figure out what MIB is needed here, load that MIB into our network management system, and then we can figure out, okay, what we're dealing with here are interface statistics. But what interface? We still have this undecoded number there. And there are ways, again, using the same SNMP MIB to figure out what that is. And at the time, SNMP made a lot of sense. This encoding really worked on the wire. For slower networks, where they really wanted to make sure they packed as many bits as possible, SNMP made a lot of sense. But it didn't really go very well with modern networks. We have faster interfaces, and it certainly didn't help with configuration management. So much so that the IETF now has said there will be no more read-write SNMP objects. It really wasn't designed for configuration management, and it didn't do well for configuration management. Instead, the IETF decided that a new approach was needed. Something that took a look at the environment that we were in and said, what are the challenges that we are trying to solve around configuration management, and how can we do better? And out of that were born new protocols. One in particular was netconf. And netconf languished for a while in the IETF. It was initially designed or built around XML-based schema that would kind of model the things that we were trying to configure. And then that would turn into actual XML payloads that we would feed to the device. But getting actual ratified or standardized data models for those things that we cared about configuring, that was a challenge. Time went on, and a new data modeling language was developed, this thing we call Yang. Yang was purpose-built for being able to model network element objects, things like interfaces, things like devices, things like routing protocols. What Yang allows us to do is take these concepts, these common things, regardless of whether you're a Cisco, you're Cisco providing a device, you're Juniper providing a device, or Arista, and model those common things in a common way. And this allows us, or the dream of this, is to be able to use these models and use secure protocols like netconf or like restconf, and be able to configure things across a multi-domain, multi-vendor network. Yang provides us this abstraction to be able to do that, to model that information, like in this example, an interface, and be able to configure attributes about that interface across the network. How many people are using model-driven management, netconf, restconf today? So a few, not nearly as many as those who remember SNMP. But needless to say, model-driven management is taking off. And if you look at why, you could take a look at the left-hand side, we see this IF index. That's the number that was at the end of that interface octets, the byte counter. That number corresponds to an interface. Yang took the working group that was defining the interface model in Yang, took a slightly different approach. What do people really care about? Well, they care about the name of the interface. This indirect way of mapping with the IF index, that was just adding complication. So when the Yang model was developed for interfaces out of the IETF, they decided to make the unique identifier for the interface a name. And Yang is kind of, a Yang module might be a little bit more readable than its SNMP counterpart. Kind of looks like a structured code, like C, for example, with the curly braces. And you don't have to deal with knowing or constructing those object identifiers, those long strings of OIDs. And this is taking off. What we're seeing is a zoo. We have a problem right now of a plethora, an overabundance of Yang modules. Cisco's doing it, Juniper's doing it, Arista's doing it. Different standards definition organizations, different SDOs are producing their own Yang modules. Some of these things live at the device level. Some of these things are abstracted across multiple devices to provide a service level model for things like L2 VPNs, L3 VPNs. They're now proposing models around SD-WAN for different domains, be it a service provider or a consumer. How do we make use of all this? How do we weed through this cat fur ball that got coughed up on the screen to figure out what are the models that we care about? What do we want to do, and how does the best way to do it for our network? So we've got a lot of models. That's not the problem. But really the answer is, and this was said by a colleague of mine and kind of became a mantra of ours. Benoit Claes was the first to say this. He said, automation is as good as your data models, their associated metadata, and your tool chain. If you just think that having all these models, having everything we saw with the cat fur ball, hairball, is sufficient, you're not figuring out how exactly am I going to make use of these models? What is the right model? I need to think about how robust they are. Where are they implemented? How reliable are they? How used are they in the industry? Can I trust them? And then what tools can I use to make use of those models most effectively in my network, either with my devices or with my services? So it really is about the models themselves, that metadata that surrounds them, and the tools that you use to incorporate them. SNMP had tooling. SNMP had commands, certainly SNMP get, SNMP set, SNMP walk. I use them still today. Net SNMP makes a great set of tools around SNMP. SNMP was woven into a majority, or a plethora, I should say, of network management systems. It's still very good for being able to collect some of that statistical data, some of that operational data from the network. But side story, I've been at Cisco now almost half my life. June 1st, I'll be there. I've been there 21 years at Cisco. I started out supporting SNMP for our customers, supporting our network management system. Cisco Works at the time in TAC. I got a lot of the questions from customers about what MIB do I need to load to decode this OID? Is this MIB supported in my platform? What's the MIB for EIGRP? We didn't have tooling that would provide that information. It was kind of a guessing game of looking through product descriptions or release notes or manuals. How do we figure out what it is that I need to use, I need to load, I need to consume in order to make use of the information my device is providing? We didn't think about that. We just wanted to get the feature in the device. And by feature, I mean actually like the OSPF, the EIGRP, the MPLS. The management came later, and that was, okay, we'll get some SNMP there. We'll have some OIDs that this thing will spit out, maybe some traps, some notifications. But how do we know how to make use of that effectively? How do we know when it comes out? How do we know at what level it's supported, and what maturity of support should we expect? That was always not even the afterthought, that was the afterthought. And these were the challenges we ran into. And this is what we saw as absolutely we wanted to fix going forward with model-driven management. with this whole emergence of Yang with netconf and with restconf. So Benoit and I started discussing it. Actually, it was an IETF here in Chicago. I don't remember the number, but it was here in Chicago, not at this hotel, but around this area. And we were discussing what are the tools, what are the capabilities that we would want in a tool chain that's kind of meta around Yang, around solving some of these problems, like finding that right module and the right nodes in that module to do what you want or to get the outcome you want. If you're a module author, if you're defining like your own service model for your organization, what best practices can you leverage? What other things that people have already defined, that people have already taken the time to build some complex regular expression to say, to describe an IPv6 address? How can I make use of some of that and know that it's trusted, know that it's good, and then figure out where those things are supported from a device level, across vendors, across different platforms within a vendor, across different software versions. And then as we start to, as a customer, as a user starts to make use of Yang, these things are naturally going to evolve. They are going to change. Just like any piece of software, you have a version 1.0, 2.0, and so forth. How do we reference or refer to those changes? How do we enable somebody to go from a 1.0 to a 2.0, know what changed, and feel confident that the applications they've written around those modules are still going to work? How do we validate that the modules we're writing are proper syntax and recognize how one module might impact another, especially as we start defining these things? We wanted to create this tool chain at the very beginning. And we didn't want to just do it for Cisco, because both of us work for Cisco. We wanted to do it for the industry. It was not just about a vendor, and it was not just about an SDO. It was not just about the IETF. It was, how do we go out to the IETF, to the Broadband Forum, to MEF? How do we go to Open Daylight, to Arista, to Huawei, to Juniper, bring everyone together and build this common repository of that metadata, of the thing that's going to help people move from the SNMP where they are today into a more model-driven or Yang model-driven world. That was the goal. What can we start to build? And we wanted to give that out to the community. How can we build that community around this so that we can make these tools effective? The answer was the Yang catalog, or is the Yang catalog. So we decided that we didn't want to be a clearinghouse for Yang modules per se. We didn't want to collect all of the modules and disseminate that from a central point. But what we did want to do is be the single repository for that metadata and provide a place to come to find the tools that you need to understand all that I just talked about. How Yang models can be incorporated into my solutions, and when and where they're going to be supported. Admittedly, we're probably not the best GUI developers, but the idea was to plant the seed into the community and start to bring operators, start to bring vendors, and start to bring other standards definition organizations together to help flesh this out. And as it grew, we added more tools, more capabilities. And as we'll see, there's a bright future now for the Yang catalog because we thought of this, or we thought of doing this more as an open source project from day one. The first thing that we wanted to create, the first thing that from our experience came to mind was, how can I find a module, and more specifically a node within that module, that's going to help me solve a problem? If I'm trying to, for example, in this case, manage or configure VRFs on my device, how can I find what Yang modules are going to pertain to that, and then try to identify a node that will give me either the information I want or model what I need to configure to the device? And we can start from there and then expand that out. So the Yang catalog provided a search interface that took some basic parameters and gave us a look at what was in its repository, what it knew about. It gave us things like the path for being able to reference that particular object, for example, in cases of telemetry, like Craig was just talking about. It gave us the organization that created the module. So for example, if you are trying to configure a Cisco device, perhaps using a Cisco module will work for you. However, if you're not, or if you're looking more for a standards-defined Yang module, something perhaps in the open config world or in the IETF world, you can get a quick glimpse at who defined this module. Do I trust this organization? Is this organization kind of the standard, or is it the approach we're going to take for managing our network? And then very importantly, understand where in this module's life cycle it's at. So in a standards definition process, a module may be in a draft state, or it may be ratified, for example, a full standard. Knowing where a module is can help you determine how much can I rely on this? Can I really count on this node not changing, that the information it's going to provide is going to be valuable now and in the future? We also have, though not seen here, how many times is this module or this particular node referenced in other modules? Again, giving you that perspective that if I found something like, for example, a type def for a MAC address, that I can trust that if it's been referenced by 300 other Yang modules, and it's defined by an organization that's more industry focused versus a single vendor, I can kind of trust that that definition is reliable. That if I'm building a service module or any other module, I could count on that. That's a reliable, well thought out definition. The other thing we wanted to do is provide a holistic view of the metadata around these modules. Some of this metadata is fairly obvious. Some of it's built into the module. Other, not so much. For example, we wanted to pull in supporting documentation. If a module had been defined in an industry standard, as an example, pull in that standard. Oftentimes, being able to read more about why a module is defined the way it is can give you better insight in how to use it. We also wanted to give you the ability to look and see where a module is supported across not just Cisco, but any vendor or any implementation of that module that might exist. And as vendors contribute their metadata to say, here are the modules that we support in this platform and in this release of code, that is programmatically inserted into the catalog and provided in this metadata overview. For module authors, we wanted to be able to provide a picture of what a module's impact is, be it what modules affect this one, meaning what does it import into its scope, and how many other modules does this one module affect. And what we've been able to do with this is identify where we're seeing bottlenecks, for example, in the IETF, and be able to apply pressure to get them ratified to standard. Because there are a lot of operators that take a look at what's happening in organizations like the IETF and think, I would really like to use IETF foo-bar, but that module is just languishing there in a draft state. And in a draft state, any one of those nodes could change at any point. How do I know if I can trust it? I'm really waiting for that to be a standard before I know I can trust it. Same thing with the vendors. Should we really implement this draft standard, or should we wait until it gets ratified as a full RFC? What we were doing with this is taking a look and seeing, okay, if we need to get, for example, the IETF RESTconf module ratified so that people can start implementing the RESTconf protocol in their devices and their customers can start trusting that implementation as something that isn't going to change, here are the modules that we also need to push through the IETF. And it was allowing us to optimize some of our process, make things better, ultimately for the end user. And it was this visibility across all of these tools that we just didn't have at the SNMP, in the SNMP days, because no one was thinking about the adoption. No one was thinking about just beyond the use of the protocol. How do we make sure that what we're defining can actually be adopted by the end users, by the operators who need these capabilities. We didn't just want to stop at building tools, though, building GUIs, because clearly we're not the best GUI designers. I'll be the first to admit. Give me a set of backend, CLI, Python any day. Don't give me anything that I need to do with Flask. Don't give me anything where I have to build a Jinja template for HTML. I just don't think like that. But we wanted to be able to say, we're putting together a lot of this information. We're stringing a lot of this together. How can we allow operators, or how can we even allow vendors to incorporate the tools we're building into their tool chains? So everything we put up in the Yang catalog, we put a RESTful API behind it. We wanted to make that wide open as well. Admittedly, we should probably add some, not secure, we should probably add some authentication to that. But initially, we made it wide open. HTTPS, but anyone can use this to get a programmatic view at any one of these tools. We released a Postman collection up on the Yang catalog site to kind of demonstrate some of the capabilities. How do we make use of some of these tools? And all of the tools themselves use those same API calls in the back end. So for example, we have an API that given 2 versions of a module or 2 revisions of a Yang module, it will show you what has changed. It will show you, have there been any backwards incompatible changes between those versions that could impact the applications on which that module, that rely on that module. And this is, again, part of helping people trust and helping people adopt a Yang or model-driven approach to network management. And every one of these APIs, on the search down to the metadata details, all covered by the API. We didn't just stop there. In fact, starting-wise, we started out of these IETF hackathons. The Yang catalog was born out of a desire to give back to the community. Just a bunch of volunteers. We kind of grew in number over time, but a bunch of volunteers coming together to do this based on the pain points that we had all experienced. Myself from a support standpoint, same thing with Benoit, some vendors from their own support standpoint, and we had operators join us as well. Just now, the IETF LLC has taken over the Yang catalog to sustain it, to be able to provide a server, resources, and admin to stand up https yangcatalog.org. But the code is fully open sourced in GitHub under the Apache license for anyone to contribute, to take, to fork. That intent being that we want people to start to use this. We want people to see value in it, to offer suggestions, and to help us improve it. It is only by building the community, building the metadata that's stored in there, and helping solve the use cases that you come up with that is going to make model-driven management successful and sticky, and it's going to help us solve the problems that we're facing in today's network. Questions?